Alright, so for my project, I decided to see what the probability that a randomly generated matrix would be invertible. To do this, I wrote some code that would first give me the determinant of a matrix, and then I used that to determine whether or not it would be invertible. So first, I'm going to go over two examples. The first is going to be this matrix right here. Taking the determinant of this gives us -2. And then for this one right here, taking the determinant of that gives us 0. And then working from that, I took the reduced row echelon form of this matrix. It tells me that this is a independent set. Each vector is independent of one another. And because of that, we can take the inverse of that matrix. And you can see right here that the inverse of A is -2, 1, 3/2, and -1/2. So for this one right here, I took the reduced row echelon form of that matrix. It shows that the two are dependent on each other, so this is not an independent set. And because of that, there is no inverse when you try and take the inverse of it. You can see that because you do not end up with the inverse in the second row reduced echelon form matrix, that there is no inverse. And going back to the invertible matrix theorem, we know that the columns of A must form a linearly independent set in order for the matrix to be invertible. And then down here I went over a 3x3 example of taking the determinant. And to do that, it's a little bit more complicated, but you basically take the same thing and reduce it to a 2x2 and then take a determinant of that. This one right here gives us 0 for the determinant. And then because of that, we have no inverse. There is not an inverse for this matrix. So the reason why this works is because if the determinant is 0, we know that the set of vectors are not independent, and in order for the matrix to have an inverse, all of the vectors in the set must be independent. So using this, I wrote some code that would give me the determinant of the matrix, and it would check whether or not the determinant was 0. If the determinant was 0, we know that there is no inverse and the matrix is not invertible. If the determinant is anything other than 0, it means that the matrix is invertible. So what I did is I checked a lot of different size matrices. Each one is a square matrix, and you can see that from what I did, I ran for the first about 8 sizes of matrices. I did about 10,000 iterations to check whether or not they had an inverse or not. My calculations, I used a matrix that was randomly generated with a number between 0 and 10. I did this to try and condense and make the math a little bit easier. Instead of having a lot of decimal values, I tried to make them all whole numbers. So I found that 100% of all of these square matrices were in fact invertible. So out of all the randomly generated matrices I came up with, every single one had an inverse, meaning that the determinant did not equal 0 for any of these matrices. I also did it about 100 times, 100 iterations for the last 3 sizes. This is because the program took a lot longer to run for such a large matrix. And for these as well, my numbers came out to about 100% of these matrices were invertible, meaning that their determinants were not 0. So that's basically it for my project. That's what I did, and that's how I went about it.